Hello, good afternoon. Why don't we get started here? Welcome to the Iris On Demand Cloud Services session. It's going to be, we should have updated the title somewhat in the abstract. I'm going to share the floor with Sam, and it'll be, when I'll go through what we'll cover in this session. But real quick, my name's Todd Sylvester. I head up cloud services at InterSystems, and a bit of background is I've been in the data and analytics career, and both in the open source with Hortonworks and Cloudera, and then the enterprise space with Teradata. And Sam, I don't know if you got a chance to introduce yourself on the main stage, did you?
I did, yeah, but I can just reiterate that real quick. So I'm Sam. I work in systems development as an engineer. I really am focused on cloud services, so exactly what this is all about. I've been doing that for about 3 years now in InterSystems, but I've been around InterSystems closer to 5 through internships and other things.
All right. So today, in this session, so I'd like to present to you the intent was to go over basically an overview of the cloud services that we have available, the investment strategy behind that, and where we're headed, and then I'll cover some of the application of the cloud services from a customer standpoint. And then I'll hand it over to Sam, who's really going to get into the next, the new initiative, the next architecture that you saw a glimpse of this morning in the keynote. Just a question, who was not at the keynote this morning? All right, okay. So I'll present the two of you because you might have recognized this slide up on the keynote. So my takeaway was make sure you find out what's being presented at the keynote before you go to your sessions here. Because here's my version of the slide, and then you see Scott Now's, which has got beautiful marketing layout on the big screen. And then I thought, well, I'm going to give the same pitch. Repetition is not a bad thing. And then Jeff gets up and shows the exact same thing that I was going to share with you. So I think it's going to be the Sam show for this session, really get into it. But let me go through some of these areas. Obviously, from a cloud services perspective, we offer across the as-a-service spectrum. So the infrastructure as a service, think of this as the bring your own license area. So these are transactable through the marketplace of the cloud providers. It's Iris and Iris for Health. We have paid listings as well as bring your own license. It's really it's traditional hosting. So you're on your own. The platform as a service, so the next level of sophistication, this is really around our managed services offering. So we do have Iris and Iris for Health managed services, both on AWS and Azure. And these are engagements that with our managed services operations team that deliver these, basically the platform where we're handling a lot of the day one, day two operations behind the scenes. So we're doing the provisioning, the deploying, the upgrades, the updates, all the maintenance, so you can focus on your application and your business side. And then, as you've heard, our recent announcement was the release of the Health Connect Cloud, and that's also a platform as a service offering. We partner with AWS to really make a seamless migration from on-prem to cloud-based services for that. But really what the focus is that real action is in the software as a service. And this is where significant amount of our investment has been made, and this will continue to build these out. And as you heard this morning, it's really two-pronged investment strategy. One is around a vertical application. So really looking to build a suite of services around a standard. The first standard we have is the FHIR standard. And so we have a set of capabilities around that where you can think about, you can build a pipeline around the FHIR standard. So the ability to ingest legacy healthcare data, transform that data to FHIR. We have a FHIR server. You could use another FHIR server within that environment to be able to retrieve, store, publish, subscribe to those FHIR resources. And then if you got a chance to see some of the SQL Builder side, it's really the ability to infer a relational model on the fire resources to be able to do, any kind of a SQL schema, any kind of analytics against that fire. So that ability to start having this suite of services around a standard, you'll start seeing that more in the financial services side and as we move to verticals. The second investment strategy is the horizontal play that we'll get into a little bit more, and this is really around Iris Cloud. So basically taking Iris and delivering cloud services in incremental capabilities on the platform. And really what this is focused on is that majority of these enterprises, it's probably rare that they're starting, when they move to the cloud, they're looking for an all-encompassing large software platform to be able to rebuild their apps. They're looking for discrete capabilities. And this is really where the cloud advantages come into play. The cloud service providers, application providers, they're delivering discrete services that you can build an application. It's really like a modern application development where you're looking for a service, it's ephemeral, it's easy consuming, you can scale up, scale down, no commitment, and these are how these applications are being built, and that's exactly what we're doing with Iris. Really focusing on how do we slice Iris in terms of delivering a SQL endpoint, delivering a machine learning type service that you can go after. So if you think about enterprises where they're looking for a SQL endpoint to be able to do ingest and analyze customer data, they want to be able to build, train, and deploy a machine learning model to do customer classification. They want to be able to have a document database interface to be able to work with a flexible schema to analyze customer interactions. That's what they're building. They need these consumable services to go build that application. And that's exactly what we're doing in delivering the Iris Cloud set of services for that. And you heard the theme earlier today, they're composable. So the idea is that you can plug and play these services on a canvas. So you can build a workflow how you need. So I just use the example of the fire, right? You're basically building an ETL, you're having an ingest persistent storage, you'll be able to analyze that. The same with Health Connect. Health Connect Cloud, we built a service around the ability to hook up peer-to-peer and VPN and direct connect, to make it really simple to go deploy and have connectivity, network connectivity to third parties. And these are these different assets that we can plug and play to be able to deliver these cloud services. And actually in the experience lab that's going on, they're walking through the ability to actually they're standing up and deploying Health Connect Cloud, they're deploying the InterSystems Fire server, they're dropping legacy healthcare, they're transforming to Fire, they're dropping it into the Fire server and doing analysis on that. So it's really, working through and making that available within that marketplace. And the beauty of it is that you can start small and grow and add on these services as you need. And one of our customers, MyPL, they are a French e-health technology platform. And what it is, it's a consortium of physicians that in the oncology space are looking at patient outcomes. And they're basically aggregating a lot of disparate data from the different hospitals and providers to be able to analyze that patient data all under the Fire format. So they're using the Fire server now. They're looking to leverage the SQL Builder to start doing a lot more analytics, higher level analytics on that. And so that's what we've been positioning, is that you start with one consumable service and continue to add on to those areas. And so this whole composability, this whole kind of like microservices cloud approach is really being enabled by this new initiative, this new approach to a cloud architecture that we have. And think of it as like composable architectural modules that we can quickly put together and build, that Sam is going to walk you through that, and then I'll come back and talk a little bit more about the future and other investments that we're making around this.
All right, thank you, Todd. So no doubt here at Global Summit so far, you've hopefully seen a lot of really cool new cloud applications. If you haven't had a chance to try them out, I hope you do. and really get a chance to get as excited as we are here about those new offerings. So everyone's been mentioning the efforts in cloud are really along both a vertical and horizontal axis, both of which are really necessary for us as a company and really good tools in the belt of our cloud strategy. That being said, I want to be clear that what I'm talking about next is really talking about that horizontal axis. I'm not going to be discussing the architecture that underlies things like Health Cloud Connect or the Fire software as a services. These are really great applications built by very smart people I've worked closely with, but they do use a different architecture simply because both approaches to architecture are important. And I'll be talking about Kubernetes a lot, and not everything that can go on Kubernetes should. But for the things that should go on Kubernetes, we have a really great opportunity to build really extendable, composable architecture and not just services. So my bread and butter and what I've built and what I want to talk about here, we call the ICCA, or the InterSystems Cloud Core Architecture. And of course, it's children's services, so the Cloud SQL and the Cloud IML that I showed at the main stage earlier today. So what I really want to do here today is shed a light on that architecture, really talk about the design doctrine of that initiative, and break down the inner workings of Skipper, the engine that really fulfills that promise of composable architecture, and in both the services we already have and the ones we hope to build for the future that maybe you'll see at next Global Summit. So first, what's our goal for software as a service? In breaking down features into services, what we're really trying to do is take chunks of Iris and then offer those as discrete pieces on the cloud as a service. And in doing that, we're trying to provide a consistent experience, both for our customers, of course, but also for our developers. Just as you don't want to have 7 different logins for 7 different services, we really don't want to understand and have to maintain 7 different code bases associated with those. We really want to leverage our partnership with cloud providers to make these offerings easily available and digestible to you, and built in such a way so that they're intuitive for people like me to code them up without sacrificing the use of the latest and greatest tooling. So to really do that, what we really did is we aligned on a philosophy for that Skipper engine. So we really had a couple of main goals in doing that. We wanted to have scalability, capability, and composability. The Skipper framework is really what guides our cloud approach. It's the captain for our core architecture, and it's leading us through the stormy waters of this ever-changing cloud space. So we wanted to design a scalable platform that's performant so that we can gather and retain customers to help them build fast and compelling applications, and then hopefully grow with them and the friends that they refer to us. We wanted to do this with the most powerful and expressive technologies available, providing a real common breadth between the capabilities of many different cloud providers or hybrid solutions or on-prem. And we want to design it so that it was modular and extensible, so that we're able to quickly offer new services and refine old ones and swap out the tools and technologies that are no longer as necessary or current easily for the job at hand. So what we developed, I take a lot of joy in comparing to a sandwich. So on top, we have a common portal to unify the look, feel, and access to these offerings. And then on the bottom, we develop on a common backend, that Kubernetes I keep mentioning. Using the APIs of both, we then develop and support interchangeable application middleware pieces, which can be either unique or shared between many different offerings. And then those different pieces, when taken as a sum, really encapsulate what a service is and the functionality that that service provides. So really, we have one service that's branded as many, but the middleware parameterization of it is so flexible that we can do a catalog and a template for different services to offer different capabilities for our customers. So let's talk about Kubernetes, take a bite into that sandwich. Kubernetes is very trendy. It's probably something you've heard about before, and that's really for good reason. A quick search would tell you that it's come from some backroom in Google, I think in like 2014, and it's really become the industry standard open source solution for container orchestration in the cloud. It's an extremely powerful tool for managing the deployment, scaling, networking, disaster recovery, and many more features for containerized applications. For our purposes, it's really important to understand that it's really ubiquitous across the cloud. It's supported by really every major cloud provider. They provide it as a service, meaning that they take care of its management for you and reliability for you. And you can also easily create Kubernetes clusters both on your own on-prem clusters or have hybrid clusters, if that's your use case. You can really, in this way, span up Kubernetes that across the world and across providers. The important part here is that Kubernetes shares a common API abstraction, regardless of where it exists. And using it as our backend allows us to really ignore some of the more complex orchestration tools that are uniquely provided by different cloud providers. Instead of having 5 solutions for 5 different providers, we have a single solution. And in a way, that means that Kubernetes is our cloud in the cloud. So using Kubernetes, we get that 100% guarantee of compatibility between any underlying implementation, and we can expect the same exact experience on any cloud provider anywhere in the world. And the cluster running on your laptop or a hybrid cluster you may have will have the exact same API and interface. Using that common foundation, we can then really build out middleware that's very flexible and consistent and powerful. And we can use that to really interact with Iris and with our software as a service solutions in a really unique way. So just before we discuss those interchangeable pieces I like talking about on its own, let's talk about the API layers that glue all of this together. There are 3 main brands for the API in the Skipper architecture, in our core architecture, and they correspond loosely to that sandwich I keep bringing up. Between the common portal and our applications is the Portal v3 API, and then between our middleware applications and our backend is the Kubernetes API server endpoints. And then thirdly, we use the cloud software development kits, or SDKs, to really do all the glue work in the middle to make this more philosophical take of our architecture back down to reality for our actual cloud providers. Portal API serves as a management engine for users. It's how users would sign up, get email confirmations, edit account information, and certainly, last but not least, get billed. The authorization context for that's really cool because we use that throughout the entire stack for end-to-end authentication and encryption. This really lets us isolate and display a protected slice of a really, in the end, a shared Kubernetes environment with many users on it, a multi-tenant Kubernetes environment. The portal itself also keeps some state for assigning physical deployments to subscriptions and users attached to those, providing really the essential service of informing a user what resources they're using and what they actually have to pay out of pocket to sustain them. I should also mention that all our offers, not just the ones using the InterSystems Cloud Core architecture, all use this common portal and this common portal API. Then on the other side of things, we have the Kubernetes API server. By directly invoking the API server, we really are directly interacting with our underlying Kubernetes and really getting to the platform directly backing those services. And I want to let that sink in for a moment because that's really cool. By interacting directly with the API server, we have native and programmatic access to every artifact that composes Kubernetes. It gives us really truly complete control of the structures in our software as a service offerings and allows us to construct, operate, consume anything within our backend or anything that's even possible to configure within Kubernetes at all. That capability is really the core of what lets us offer our services on Kubernetes at all. It's the reason we can really provide and tailor an experience of both a Kubernetes expert and an Iris expert, both as a code and as a service. And then, although Kubernetes provides that cloud in the cloud experience for us, there are many providers and tools that deploy clouds of stack resources because we can't really escape the cloud altogether. We can't just rely purely on Kubernetes because we have to deploy it in the first place. there are options in all the cloud providers. There's CloudFormation in AWS. There's the Azure Resource Manager in Azure. And then Google has something called the Deployment Manager. There's even cloud-agnostic approaches, such as Terraform. So I feel I should explain why we're using the SDKs here directly instead of using one of those solutions. By directly using those SDKs, we have really the tightest possible integration with provider-specific resources, at least the ones we do actually use. And while the other options are very expressive, they're not quite exactly what we want, and they fall a little bit short on customizability and descriptiveness for what we actually want to put in the cloud. Using the SDKs, we don't have to keep state or separate state files or templates for our infrastructure, and we don't have to code around the limitations of these tools. For instance, if you create a container registry and you want to push something to it, you don't have to have code after the fact to do that process. You can do everything in a single natural order and within a single application. So the SDK there is really the glue that ties our philosophy to the reality of those disparate cloud providers. We use the SDKs really only when and where we need them and in the most minimal and coherent fashion we can. And that way we can really ensure that everything we do that has the SDK components has direct equivalence in other clouds so that we're never left out to dry when we're trying to move on to different cloud vendors. So by now, I should probably talk about that good middleware I keep referencing. You know, there's Portal, there's a backend, Kubernetes. We have the APIs that do all the interaction between them. So what's the meat of this? How do we actually make this work? What are those powerful, reusable blocks that I keep claiming compose these services and allow us all this power and flexibility? The answer, as you might expect, is our code base, but not just the fact that it's a code base, but specifically its organization. What we really have here are two independently buildable, stackable extension libraries. So let me get in that a little bit. So we have one for Kubernetes operators and controllers. Those really interact with pre-built solutions, things we use for networking, storage, monitoring, et cetera. Really best-in-class things we don't have to invent again. Things like Splunk or Longhorn or Calico. And then the second library we have is really everything else. It's the serverless containerized operations, the functionalities that we really build custom for things like launching Iris, moving files, fetching logs state, doing upgrades, stopping, starting Iris, et cetera. Even auto-scaling and billing would be included in that. So when putting together a cloud service, these two libraries really correspond directly to what environmental dependencies and tools we require within Kubernetes, and then what code we actually have to run against instances of Iris to manage their life cycle and do the operations within that environment that actually do the real work of a service. So for Kubernetes extensions, we do something really cool. We don't really want to limit ourselves to any subset of tools. We don't only want to offer Longhorn, but not something like NetApp on Tap. So what we decided to do was make Skipper able of utilizing really any Kubernetes extension that follows a standard installation. So when someone at InterSystems has a cool new idea that requires some additional dependency for a service, it's really as easy as pasting that into our library, maybe adding a Helm chart definition there, and then selecting that it's needed for whatever template a service is described in. For the other library of custom-built components, we have more breadth of functionality. What they do have in common is that they're containerized serverless functions, and they do many small individual features for a given cloud offering. So they're really microservices. They're really built anywhere. They're built to run anywhere that a container can run, any invocable containerized environment, which means that we could use things like Amazon Lambda or equivalents in other providers, or we could even run them within our backend Kubernetes cluster itself. So we want to make those eminently portable. Many of those serverless functions are kind of directly attached to the UI. They run anywhere. And then some cool examples of those that are not exactly what you think. So you have options where you say, it's easy, you move a file from A to B. But there's also cool things that you can put in that Kubernetes cluster really as cron jobs. So things like auto-scaling, for instance, you can run directly in the cluster to actually minimize your dependencies on other things, because when you're auto-scaling, what you care about is actually in the cluster itself. So you can make sure that you're not using anything else. You're using just pure Kubernetes for your auto-scaling solution, which is pretty cool. In the end, these two library extensions really mean that any service we create is really just defined as a catalog of what extensions it needs, and is really able to be explicitly defined within a single file. So then how do we get from that collection of extensions and microservices to an environment that really actually works? Now, it would be nice if all of that middleware was easily categorized as something that deals with Iris or something that's a Kubernetes extension. But as you might imagine, the reality is a little more complex than that. There's no better example of that than the infrastructure microservice that actually launches Skipper. So really, the launcher for all of this is itself part of the middleware. It does all of the interconnection work for hooking up endpoints to those middleware components, and actually does the install for all those Kubernetes extensions and operators, etc. So although it sounds like that deployment should be a separate piece of what our architecture is, the truth is that it's within the middleware itself, and that Skipper effectively builds and provisions itself as an endpoint. A really cool example of that is something that's been floating around here at Global Summit. Maybe you've heard of the Smart Data Service. It's been on a number of the slides on the main address or in things about the cloud. But really what that is a very powerful option where this is what you saw the other day, where they were dragging and dropping elements, and those were auto-connecting within a Kubernetes environment. But that entire system is actually encapsulated in a Helm chart, meaning that we can actually add it as an extension simply within that Kubernetes element of our libraries. And then we can provision Skipper, a flavor of itself, on a per customer basis as an endpoint within the portal page for the Smart Data Services, which is really cool. So yeah, to just kind of reiterate that, because I really love that point, Skipper makes itself available, the build and deploy step of itself, as a service. Of that kind of functionality, of course, really kind of grays the line between having these dumb single task microservices and things that are supposed to be more architecture aware applications. So I think the deployment step here really deserves its own special consideration, and really is a special case within those libraries I mentioned in our middleware. So while most of those are, as I said, those small singularly taxed services, and although the deployment shares the same portability and statelessness of the other middleware pieces, it's more macro scale than microservice. And it's really the keystone of the architecture, and within it, it internally contains all of those templates I'm talking about for our services. So another special case of our middleware, and really the flip side of deployment, is those things that deal with administrative tasks. So just like the actual deployment of a Skipper environment is stateless, that means equivalently that we actually have to have side applications that do the day-to-day monitoring of this environment. So things like auto-scaling, we need to keep direct track of the resource utilization in our underlying Kubernetes environment, and not just respond, but preemptively react to changing requirements for machines, memory, storage. And we want to scale up when we see new users creating new things, and scale down when they tear them down. And we want to do this so we're not thrashing too. So we want to create buffers to get them up to speed quickly, and to make sure that we're not creating and remaking the same machines over and over. We also want records of what resources we consume in the cloud, so that we can detect changes when we say, put out a new version of the InterSystems cloud core architecture. And we want to assign things within our environment to specific customers. And as a whole, really explain where our builds are coming from, so I can look my boss in the eye. So, and then when things go wrong, of course, because things will always go wrong, and really at any level, whether that's Kubernetes, Iris, any component of our internal libraries, or maybe something just in the cloud itself, we want to have access to intelligible logs so that we know where to go and what to do next. So between deployment, administration, and then those more operational middleware components, we really see a further breakdown in what I was calling our extension libraries between what microservices are common to the architecture of really all of our on-demand services versus which ones are common functionality or perhaps unique to individual services themselves. So what does this give us all put together? Putting this into context, what are we left with? So we have an engine that's built of many interchangeable and composable pieces. One library components for our backend Kubernetes environment, and then another for Iris in the cloud. And then we have that additional breakdown into special cases for both the deployment and then administration of the overall cloud stacks we provision. Because of this organization, any service that we build or can dream up in the future can be defined as a subset of those extensions and be templated within our architecture as a catalog both of those extensions and their interconnections with other microservices and the invocation rules about them for the portal application itself. We can build features used by multiple services in a single code base, which really allows us to do a rapid release and refinement of these services on demand. And we can use the best technologies here because we're separating ourselves from any one language or tool using containerization. So really the only limitation we have for what we can build and run as a service is constricted by our API, which then again, we also have control of, at least the portal API, so we can change based on our needs. And then all along the way, we have the power and scalability of Kubernetes itself. And we have that anywhere in the cloud and beyond because we're leaving ourselves open for hybrid cloud or on-prem as well. In sum, hopefully you'll agree with me that what we've built here is not only amazing, but really meets those original goals I told you of scalability, capability, and composability. So there's an overall diagram of Skipper here, which I didn't want to show you at the start because it's pretty big and scary. But here it is in all its glory, the description of the Skipper engine for our on-demand cloud services architecture. You can see here that we have the administration part and the deployment part here at the top. You can see a categorization for the Kubernetes extensions as well as our plug-and-play middleware pieces. On the bottom, we have our Kubernetes underlying platform, and then up on that left, you see our integration with our cloud portal. And with that, I'll hand it back to Todd.
Yeah, before you leave that slide, any questions or comments regarding the cloud core architecture that we can address for you?
I know I did a lot of talking at you, but there's a lot of content there, and I hope that altogether the main points I got across show you that we have a really powerful, cool new tool.
I guess it would also help if there was a use case, that you can imagine that when you use all these parts, as you installed them or created your imaginary use case, you implemented these things as you went through them.
Yeah, we don't even have to imagine. So part of what I showed on the main stage today was transitioning from a Iris Cloud SQL instance to a IML instance. Actually, I've been told I'm supposed to say integrated ML, not IML, so that I don't get in trouble. But that transition is really just a swap where we're taking the Iris container itself and changing that for one with IML enabled. And that's just a single middleware piece difference between those two environments. So they're running off of entirely the same code, except for that one small little piece.
I see IPO under your different extensions diagram. I know that's the InterSystems Kubernetes operator, it's something else.
Yeah. So
If we're using IPO directly,
it's not using IKO yet, but that's in our roadmap. So to kind of pat ourselves on the back, part of those Kubernetes extension libraries we have include things we build ourselves for the operation of Iris. So IKO is included under that. And as we scale out to more platform as a service offerings, we'll be using that more for things like mirroring or maybe integrations with things like the system alerting and monitoring or IAM, and putting those in there as parts of our software as a service offerings.
and I guess a follow-up, without IPO, how are you directly deploying the Iris components then? Is it like directly calling the cloud SDKs? Like what replaces IPO until you integrate it?
So replacing IKO in the case of provisioning Iris, in this case, is direct Kubernetes. So really, we're talking directly to the Kubernetes API server. We're creating a stateful set for Iris for these applications, and then directly editing, creating, deleting, and pause, stop, start, etc. for those stateful sets.
How much, like, what degree of customization do users get on either the tables or the Iris instances themselves?
So because these are software as a service offerings, none currently. There's a grand dream literally up in the clouds where someday we'll say, I would like Iris with this, and this, right? And really compose your own template for the service offering you want. But that's not what we do today, and may not be, but that's my dream. So I'm not going to go on the line to say that InterSystems will do that. But we would like to have that capability, certainly.
What about individual tables though? I feel like say you want indices on certain properties, like that.
Oh, so like kind of once you actually have Iris up doing things on it? Yeah, so that's part of what we want for part of our middleware applications, right? We want to be able to do things like preload customer applications onto something software as a service, right? That is not currently anything that Cloud SQL or IML does, but that is also something we're considering for the future.
One of the slides back early in deck said InterSystems Network Connect.
Yes.
Can you kind of explain what that is?
Yes, the Network Connect is a service that we built to fit a need of being able to connect basically multiple sites to providers. So whether you're using Direct Connect, peer-to-peer, VPN, it's our way of sort of just having a hub and spoke model for that, specifically for Health Connect Cloud implementations. Yeah. Yes.
Yes. Yeah, you maybe told it already a bit, but is it, do we have a glance at how the future of InterSystems is going to look like? Because you also put it the possibility to install it on premise.
Exactly, so that's definitely part of our roadmap. That's something I actually probably when I go back to work on Monday will start doing, is both looking at running this on Kubernetes clusters on other clouds, and then also things like hybrid cloud or on-prem. So that's absolutely on our roadmap for this.
So I wanted to point you to a couple, if we could do one more slide. So there's a couple of cloud services that we talked about earlier. So Steve and Rick are presenting right after this. They're getting a deep dive of the Iris Cloud SQL offering. Then tomorrow morning, we have an in-depth overview of the integrated ML cloud service. And then Gopi, what's your session tomorrow? Sorry, I didn't have it up on the slide. 2:30. What's the title?
That's 5 technologies from InterSystems and database.
Yeah, so it's a combination of the partnership on that and the cloud services built in that. And I encourage you to attend that as well.
Yes, and I believe there's one before that too on AWS trigger architecture, which is also talking about some of our more vertical applications for our cloud offering. And those really are hand in hand with what we're doing here. So highly recommend looking at all of our new cloud stuff, which includes those.
And if you just go 2 slides down. And I do want to, there was a called out a couple times, one more. Please, if you can take a look at the early access program. I know we talked about this morning on the keynote, but this is really critical for feedback as well as your input in terms of some of the prioritization and the investments that we need to make for that. So much appreciated on that. With that, if there's no other questions, I want to thank you very much for your time. Thank you.